Hi, I'm Jonathan Hall. This video is a recording of a presentation I did when I was working at Bugaboo back in April. It was a recording of a sort of a group discussion, a presentation I did about a book I've read called The Mikado Method, and how I've learned to adapt it when I'm coding, and how you can adapt it maybe in some other situations too. The production quality is fairly low. It was just a low quality recording of a group conversation. Unfortunately, you cannot see any of the people in the video, only the slides, but you can hear our voices. Some of the comments are a bit hard to hear. I apologize for that, but I think you can get the gist of the conversation. And I also recreated a small portion of it, the interactive whiteboarding session, so to speak, so that you can get the idea a little bit better. Links to the book and other references are in the description. Don't forget to like and subscribe if you find this information useful. And thanks for watching. Welcome, everybody. Today, I'm going to talk about the Mikado Method, or Mikado, or Mikado, or Mikado. I don't know how it's actually pronounced. This is a Japanese word, and I don't speak Japanese. But I'm going to teach you all how to increase your productivity, your workload, and your sex appeal with one simple trick that the experts don't want you to know about. And the button.
No.
All right. So I am going to talk a little bit about development, but this isn't strictly about development. But the first part, I do want to talk a little bit about development. I think most of us in the room right now are developers. I think most of us like greenfield projects where we get to start from scratch, we get to design things, and everything's nice and pretty, and there's no legacy code to deal with, and there's no mysterious modules we don't know what they do or whatever like that. So, you know, I think greenfield project pretty much everybody's sort of ideal scenario when you're writing code. Would anybody disagree? Nobody disagrees? Unfortunately, at least in my experience, greenfield projects are kind of a myth. Best case scenario, you have a greenfield project for about 3 months. And by that time, whatever was greenfield at the beginning is now legacy code, and you have crap to deal with. So the Mikado Method is a way, it's an approach to help deal with non-greenfield projects. I would say, if you're lucky, you get to work with a clean architecture with a few nasty bits. If you're unlucky, you have what's called a big ball of mud. You know, it kind of works, but nobody really knows why. Nobody understands the full architecture. There isn't probably an architecture. It's mostly just random spaghetti code stuck together. Show of hands, who thinks our project is closer to that side? Who thinks it's closer to this side? Pretty unanimous. All right. What's wrong with a big ball of mud? What's wrong with this problem? What with this scenario where everything that we don't understand everything? What are the practical implications that you experience on a day-to-day basis? Anybody?
Don't know how things work.
Don't know how things work. Okay.
So you have to spend time.
Spend a lot of time digging through.
Slow.
Slow. Okay.
Using
Documentation. Anything else?
Breaking something else, and you eventually fix something else.
Things are fragile. You fix something here, something over there breaks. You don't know why.
Nobody wants to touch it because they don't know how to break it.
Fair enough. Yeah. So all of these go together to be our problem set. Can we fix this? How would you go? What are some approaches you take, or would like to take, if the world was your burrito, so to speak? How would you address these problems? What would you do in our code base or in general? Anybody?
Detect Godsmans.
I'm sorry?
Detect all possible.
Okay. Probably with a tool like SonarQube or a linter or some static analysis tool that can help. Yeah.
Small steps.
Small steps. Okay.
Yeah, like focus on one thing, fix it, and do another one.
Okay. One thing at a time.
Define a problem and just split them into chunks.
Okay.
Write tests so that we can refactor it.
Write tests.
Kill features.
Kill features. Make it so reduce the size of the problem set. Nobody's advocating for a rewrite. No?
It says starting from scratch.
I did.
You did say start from scratch. You did. Okay.
Yeah.
So we could come in like a wrecking ball, but no, don't do that. Please don't do that. One of my favorite blog posts by Joel Spolsky talks about this, about rewriting from scratch, and how, as I mentioned at the beginning, everybody likes greenfield projects. So everybody, maybe most everybody, maybe not literally everyone, likes the idea of rewriting something from scratch. You know, something's broken, we don't know what it is. We want our code to look kind of like this, right? We want tidy rows. We want to know what it's for. We want to know what everything does, and it's nice and clean. This is an actual photograph from a German forest, before and after. And I don't know exactly when this was, since photography was around. It's probably in the 30s, probably during the Third Reich era or something like that. But they decided to do scientific forest management, like this. And the trees were clearly easy to understand, but they didn't survive very well. They got sick, and they started to have pests, and I don't know all the problems. But I think we're very tempted often to aim for this without recognizing that this is actually necessary sometimes. And I call this, I get this from a blog post that I like, but he talks about the concept of legibility. And often we like to aim for legibility without necessarily recognizing what's going on. And I see that when we aim for a rewrite. If we try to do a rewrite, we often forget all the little tiny bugs we fixed along the way. We forget about that, oh yeah, there's that weird bug in Outlook version 2003 that we have to work around in this weird way, or whatever the situation is, right? And we forget about those little weird bugs. Our big ball of mud, as ugly as it may be, does contain a lot of wisdom and a lot of information that we lose when we do a rewrite. So I like to encourage you to not do rewrites. Joel Spolsky likes to encourage you not to do rewrites. He actually called his blog post "Things You Should Never Do," and he talked about rewriting. So this brings us to the Mikado Method. Mikado Method is a method to add new functionality or to refactor in small autonomous steps without breaking your code base. The name comes from this game. Has anybody played this game before? It's a variation of pickup sticks. You basically try to remove one stick at a time without moving any other sticks. So that's where the name comes from. Is you can change one thing in your code without touching anything else, without disturbing anything else. And if you do that enough times, you can have a big impact on your code, of course.
Provided we have many sticks and not just one long.
If your code is small enough that you can call it one stick, maybe you could just go ahead and do a rewrite. Maybe you'll do the right thing. This is the book that this presentation is essentially based on. I have a copy upstairs. It's my personal copy, but I'm happy to lend it to anybody if you want. And it goes over the 4 basic steps of the Mikado Method. And in much more detail than we'll get into today. The first step is to set a goal. Think of what you want for the future in your project, whether it's the goal often might be a story, a user story. Could be a package that's too big, responsible for too many things. You want to break it down into smaller packages, whatever. So you have a goal in mind for your code. It doesn't have to be code, but I'm going with the code first, and then I'll go to a non-code example at the end. So you set a goal. Then you're going to experiment about that goal. You're going to actually change the code. You're going to play with it a little bit and see if your change makes sense, see if it's possible to do, see if it has dependencies. You're going to visualize, and there's the only artifact from the Mikado Method is a graph that I'll show you in a moment, which is what you visualize. And it could go on a whiteboard, it could go on a piece of paper if you're doing it by yourself. It can be an easy way to share parts of the story with the team if you want. And then you're going to undo your experiment. We'll talk about more detail about that. So you're literally going to do a get clean or whatever. All the code you change, you're going to wipe it out, you're going to delete the changes, and you're going to repeat the process. This is an example of a Mikado graph. So you are going to write your goal with a double circle around it. And then as you experiment, you're going to discover, you're going to uncover new dependencies that you write in new circles. I'm going to go through an example of that here. First, this is the entire Mikado method summed up in a flowchart. You start by drawing your Mikado goal. You implement the goal or prerequisite. That's the experimentation phase. And it says naively, you just do whatever first comes to your mind. You're not going to spend hours thinking about this architecture. Just do something. You're going to come down here. You're going to execute it. Are there any errors? You might have a compilation error. You might discover that it breaks unit tests. Whatever. If there are errors, you're going to come up with the immediate solution to the error. So maybe you broke a unit test in a different module. The solution is you have to make that other function take a different argument or whatever it is, right? So you're going to draw the new solution as a prerequisite. So you're going to, on your chart, you have your first thing. You're going to draw over here. Here's the add new type to function or whatever. Draw a circle around that and an arrow connecting the two. You're going to revert your changes that just broke stuff. So now your code's working again, but it doesn't have any new value. Then you're going to select the next prerequisite, the one you just chose, the one you just defined. I see some people looking confused. Hang in there. We'll get there. You go back up here, you do that new thing. So I'm now changing the type in that function that I was talking about. Are there errors? No errors this time. Okay, so that's great. I come over here. Does the change make sense by itself? In other words, if I committed this to Git, would anybody look at that and go, what the hell are you doing? Or would it actually make sense as a standalone commit? If it makes sense by its own, commit your changes. If it doesn't make sense, then you come back here and pick the next prerequisite and lump them together. Is the Mikado goal met? If you've done this enough times, you'll eventually get back to that first goal you set. Once it's set, then you're done. If it's not, you go back and repeat the process as many times as necessary to finish that goal. Any high-level questions right now? Because we're going to go through the details again. Yeah?
What are prerequisites?
Prerequisites would be anything that causes an error in this stage. So if something causes an error, could be anything. That needs to be fixed before this change can be realized. So that's a prerequisite. We're going to go through an actual coding example that probably will help make some of this make sense. As you finish your tasks, you're going to put a check mark on them. So this is a little bit larger goal here, or graph here with just filler text, but you mark one off. Goals can have shared prerequisites. So it's not necessarily just a sort of starburst pattern. You can have these loops and so on. So let's do an example. In this example, we're going to change the way an application is launched. Right now, the application uses a hard-coded path to a user data file. What makes the system this makes the system inflexible. For example, we can't change the path when we need to test our application. So we have an application. It's a Java application. It reads data from a set path. We want to make that path configurable. This is how we start the application with this bash script that runs this command. And that class, sorry for the blurry image, but hopefully it makes sense here. So here you can see on about the middle of the screen is the hard-coded path to a database.txt file. We want to make that configurable. Okay, so that's our Mikado goal. So going through the steps here, draw the Mikado goal. Use command line argument argv in launcher.java to configure the database file. So now we're going to go implement that naively. So we're not thinking ahead, we're not doing architecture, we're just the shortest way to fix it. So we change it to take argv 0. Pretty simple, pretty naive. What's going to happen next? Anybody want to predict? Now we update, now we run the sh file and we get an exception in thread main, blah, blah, blah. Java lang array index out of bounds exception, 0 at, and then line. So we're trying to reference an array that has nothing in it. So that's not going to work. So we have a dependency of some sort. We have a prerequisite. So we're going to come up with an immediate solution to the error. And we're going to draw that as a new prerequisite. So we on our graph here, we add the new one, add file path to arguments in run.sh. We draw an arrow to that, and we revert our changes. So the change we made in the Java file is gone now. So our code works again, but we also haven't added a new value. So now we set the next prerequisite. We only have one. So we're going to add this argument to our file, to our bash script, right? So now we're passing that argument in. Does this change make sense? Think about that for a moment. If you saw a commit and the only thing it had was adding db.txt at the end of your bash script, you probably would think that doesn't make sense. Like, why are you doing that? Nothing's reading that value. So it doesn't make sense. So probably don't commit it yet. Or you might commit it, but you're not going to make a pull request out of it. So we've checked that one off. We finished that one. Now we come down here and we basically make the same changes we just did again. It's a silly example because it's so small, but we make the same changes to the Java file. Pieces work together. It's an atomic commit. Is the Mikado goal met? Yes, it is. So we've completed. It wasn't that easy. Any questions about that? Because that was a super fast, super simple example with only 2 steps, but doesn't make sense on the surface.
What is the point of undoing the changes, whereas just fulfilling the design?
In an example like this, obviously we're exaggerating. You probably wouldn't need to. And something like this, it's so simple. It's literally 2-line change. But if you're doing something bigger, you might have a really messy checkout. Maybe you've modified 6 files or something like that, and reverting just gives you a clean slate. From my own experience, when I rewrite code, I know it comes out better the second time, even though it feels like a waste of time. So I think those are 2 reasons. Sometimes when I'm doing this, I don't literally revert. I will stash my changes or commit to a separate branch, especially if I've done multiple changes that aren't necessarily related to each other. And then I'll come back and maybe reuse some of that code with a cherry pick or something like that. But the point is that, so the main point, in my opinion, is to get your code base back to a completely working state. You should never commit, or very rarely commit, known broken commits. And by reverting, you know that you have a clean working state. So I think that's the reason. Does that answer the question?
Yeah.
I'm fuzzy about following the rules strictly, but those are the principles.
So undoing stuff is not strictly required. You can still keep changes there if you want to fix something, because based on that, one might deduce, okay, you only fix stuff by changing the input of the whole thing.
Yeah.
But it might not be the solution to every problem you face. You need to keep changes there.
I think it's useful to keep in mind that the Mikado method calls for a reset.
Yeah. And
as long as we keep the spirit of that in mind, as far as I'm concerned, we're doing it okay.
So what's the point of the reset? What's the?
It's to, again, in my opinion, is to keep certain that you have a working code base at every commit. Now, I break that sometimes, and I'll be working on something that's a fairly hairy feature, and I have touched 16 files, and I start, I'll just commit 3. I commit the 3 that touch a particular function, and I assume that commit is correct. Sometimes it might not be. If I actually rewind my Git history to that exact commit, and I ran it might break because I might have forgotten one place where that thing was called. This prevents that. If you do that religiously, a reset every time, you won't ever have a situation like that. I don't pull it religiously. The authors probably won't like me for that. So those are the reasons. Use your judgment, in my opinion.
So maybe the idea is that you want to fix stuff with the minimum amount of code change.
Yeah. Yeah.
Or not touching every single version.
And I do think there's value in knowing that every commit in your history compiles and works. Because then if you ever need to revert something, you don't have to go, am I reverting to a working commit? You can just assume that every commit you revert to is going to be working. If everybody followed this rule strictly, that would be a possibility. I'm sure not everybody does that strictly, so that's not always a possibility, but at least we can aim for that a little bit. That's fine. I'm sorry, did you want to say something else?
No,
okay. All right. I did promise some sex appeal, so let's do a live example here about some sex appeal. Say our Mikado goal is we want to increase our sex appeal.
As you do.
I really want to increase my sex appeal.
Who to though?
Sorry?
Who to?
It's a good question. It's an exercise for the reader. But that doesn't really change the goal, does it? Depending on who you're trying to be appealing to. What are some things that anyone might do? It could be you individually or just generally would do to increase sex appeal. What's one of our prerequisites?
Dress up.
Sorry?
Dress up.
Dress up. Okay. So we're getting ready to go out, we're looking for a date, and don't feel like I'm sexually appealing enough, so I want to dress up. And I go to the closet, and all I have are t-shirts and jeans. What do I do next? What's my next shopping. Go shopping. All right, so I've gone to the supermarket or to the mall or wherever it is, and I pull up my wallet and it's empty.
find a job.
That's a goal.
We could go with that for a long time. Let's come back to here. What's something else other than dressing up that we could do to increase sex appeal?
Stop talking about coding.
Stop talking about code. I think that really depends on who you're trying to appeal to, as I got to a minute ago, but sure.
Or maybe start talking about code.
Yeah. Are there any prerequisites for this? If you see a shrink, if all you can ever do is talk about code?
You need to know the code to be able to talk about it.
But if you want to stop talking about it, what's the prerequisite? Are there any prerequisites to stopping talking about code?
Yeah, you have to have something else to talk about.
Something else to talk about. So what, you have to go to school for that, or read a book, or what? How are we going to accomplish that? I guess the first thing is something else to talk
Other
about.
hobbies?
Watch Netflix.
Something else.
Have a life?
Oh.
This is
Easy.
Wrong room.
Know your audience.
Where else? We could keep going down this road, or we could start with something else.
Smell good.
Smell good. So I need to overcome my halitosis. So I'm going to say halitosis. I don't know how to spell that. There's a prerequisite to smelling good. What else?
Doctor.
Go to a doctor.
Why?
Plastic surgery.
And now we're back to money again, right?
Just get rich.
Just get rich?
Yeah, win the lottery.
All right. So,
You have money, you don't need any.
so we need to really put a prerequisite in here. We need to find money. And this goes here, not here. And this goes here. And then find money to go to a job or win the lottery.
So, just get rich.
Just get rich.
Or die trying.
Maybe, well, how about losing weight? That's probably something I could stand to do a little bit. So I could go to the gym.
Cost money.
So I'm back to needing money again. I could ride a bike, but I probably need to buy one.
Eat less cookies?
Eat less cookies? Well, I don't think that's an option.
At least you don't need to find a job for that.
Do we get the idea of how to draw the graph? You can really use this for just about anything that could be broken down into small parts. You can use it for planning your garden, for your holiday, for code. I don't know how you revert when you're not doing code. Like if after I win the lottery, I don't know how to revert to the previous step. But any questions?
So after you have written this down, what's the next thing?
So the next step is I pick one of the end nodes, one of those that doesn't have an arrow coming from it. So I could choose eat less, I could choose win the lottery, or find a job, or something else to talk about. I can pick one of those, and I do it. So let's say I do something else to talk about. So I've gone to the bar, I still haven't bought my new clothes, or lost weight, or started to smell good yet, but at least I'm trying to have an interesting conversation with somebody. And it either succeeds or doesn't succeed. If it fails, I need to figure out why did it fail. And then that will become a new prerequisite for the next weekend out. Make sense? If I succeed in talking about something other than coding, then I can put a check mark here and here, right? And then I have to look for the next node with no arrows coming from it. So that would then be eat less, win the lottery, or find a job. And I pick one of those and I tackle it.
And how do you go about all the arrows? So once we chart connected.
So once I've, let's say I found a job, then presumably that has helped me get the money I need. So now the gym, go to the doctor, and go shopping are all end nodes that I can tackle. I can choose one of those to tackle. I might be able to do all at once, depending on how much money I've required. But
Can we leave this up on the board? I just want to know what people.
I don't think most people will read it very well, but we can leave it on the board, sure. This can work really well in back to the coding examples. You know, if you have a large project, you might end up with something like this, where you're doing some refactor and you have 4 or 5 end nodes, It's a really easy way to delegate that to 4 or 5 different developers. Probably, because they're all independent. They don't have any shared dependencies, at least that we know of. Maybe you start playing with it and you discover there are, then you need to fill the graph out further. But assuming they're actually end nodes, they're components that individual people can theoretically work on. So it can be a really nice way to visualize a complex problem that is shared across more than one person. It can also be great if you're doing it on your own. You can do this in a notepad by yourself for a project you're working on, just to keep track of what are the 6 requirements that I forgot about. You know, I did this and that, let me do that, let me do that, let me do that. It can help you keep track of those different requirements if you ever have that. Especially useful with big refactoring things where you have to go touch a bunch of different modules. So, yeah, that's the Mikado method. Any other questions? It's pretty simple, yeah?
It's not really related to Mikado method.
Okay.
So in the slides, you have the bubbles and the arrows. Did
Yeah.
you do it?
I copied that from the book, actually.
Okay. Did they say which tool they used?
They did not recommend an online tool, except I think just a typical graphing program. So I did do a quick search for tools for the Mikado method. I didn't find one. So I don't know of any ready-made tool, but that could be a great hackathon project next time we have a hackathon program. It would be a fairly simple tool to build, I think, if somebody was motivated to do that. Maybe you could build a Jira plugin. All right, well, that's the end of my presentation, unless there was more questions. So, yeah.
Just understand, for example, you have the bubble with lottery,
Yeah.
but it's not something that's in your control, right? How does
Perhaps not. I mean, so if win the lottery, so I mean, you could get prerequisites there. You could say I have to buy a lottery ticket. You could say I have to cheat somehow. You know, you could come up with different prerequisites. But still, yeah, you may never be able to achieve that goal, right?
Because people still buy lottery tickets in time and never win. So.
But I think the same thing happens in our code sometimes. Yeah. Sometimes we pursue a path that we just can't accomplish. Too expensive. We don't have the knowledge. It turns out to be physically impossible to bend space-time that far or whatever it is. So you have to find a workaround then. So in that case, I would take a step back and look for other ways to accomplish the same thing.
I'm just thinking, is it possible to get into a circular dependency?
I would imagine it is.
But I can think of maybe not. Maybe it's not practical. I don't know.
Yeah, I'm sure you can find circular dependencies, and then I think you just have to be creative and find a way to break that.
Life is not a program.
It's more complicated.
You have a lot of choices.
Well, losing weight can be a circular dependency in some ways, right? I mean, it's hard to lose weight because you have to do exercise. It's hard to do exercise because you weigh too much. Yeah, there's a little bit of circular dependency there.
Or in terms of money, I don't have money to buy the lottery, or I don't have money to, I don't know, buy a computer and then search for a job or something.
Yeah. So yeah, I think there's a lot of room for circular dependencies, but I think you have to be creative and find a way to break them. When it comes to code, I think it's more common that you'll find circular dependencies than losing your sex appeal, but never know.
Do you think there's much point in reading the book now that you've sort of taken
The first half of the book is an easy read. I felt like the second half was mainly reiteration. I didn't actually read the entire book. The last chapter or two is about refactoring methods, which I think is very valuable, but I have a different book I recommend for that. It's called Working with Legacy Code. It reminds me I had some further reading things here. If anybody cares, this is the book. Essay about the big ball of mud problem I talked about originally. Things you should never do, I mentioned. Legibility. And this is the book where that photo of this German forest was taken. So if anybody cares, take a photograph or I'll send you the link later.
We'll post the wiki page.
Yeah. Maybe you want to just browse through it. I mean, you can probably browse through the first 2 chapters in a half an hour and get a little more detail about what I talked about. If you feel compelled at the point to keep reading, go ahead. If not, no problem.
What do you use it for most, like coding issues or?
I use it mostly, so I'll admit, I don't usually do the graph, but I do the same experiment and reset thing a lot when I'm coding. And I used to not do that. After reading this book, I changed my habit. I used to hack along and discover this problem and then go fix that and hack along. And then I end up with this like 6 things I did in one commit and it's a big hairy commit. And then I try to separate things out a little bit like I described earlier. And I decided to stop doing that. So what I typically do now is I discover a big problem like that. I either revert or stash, fix the small problem, commit that as a separate thing, and so
I
on.
think the step back, it's a psychological thing. I mean,
Yeah.
it forces you to rethink instead of trying to dive in deeper and try to fix that issue. It really, it's sort of a tunnel vision, and it forces you back. Yeah. I think it's a clever idea.
No, it's really useful with things like maybe you're trying to add dependency injection somewhere, and it's like 6 layers down in your application. You could just go through and add that every layer, or you could just start over and go down to the lowest layer, or actually probably the highest layer, inject it 1 layer deep. Everything works. The dependency is being injected. It's not being necessarily used there, but it's being injected. Commit that and run with it. And the next one, inject it 1 layer deeper. It's not necessarily being used, but it works, and so on until you get to the bottom. Whereas if you do everything at once, you end up with, you're touching 6 different classes or whatever it is. It can be a much bigger change to manage. And a simple dependency injection may not be that big of a deal. If you start touching logic at the same time, it becomes a lot here. So something like that is a place where I like this approach. Any other questions? Any questions from the remote audience? This is the one chance you can unmute yourself if you wish. All right, well, thank you then.